You have one lifetime, not a civilization, not 1,000 generations, just you. Your heart will beat roughly 3 billion times, your bones will weaken, your skin will wrinkle, and somewhere, out beyond the thin blue haze of Earth's atmosphere, space stretches outward in every direction for billions of light years. Now imagine you step onto a spacecraft today. No sci-fi wormholes, no magical hyperspace, just the best physics will ever allow. How far could you actually go before you die? Could you reach another star? Another galaxy? Could you outrun time itself? Here's the paradox. The faster you travel, the slower you age. The universe bends to let you live longer at least from your perspective. But at the same time, the distances ahead stretch beyond comprehension. Space expands, time dilates, light itself becomes your ceiling. And suddenly the question isn't just about distance. It's about whether a single human life is large enough to confront a universe this big. You are not just asking how far you can go. You're asking whether reality will ever let you leave. You begin on Earth. The ground vibrates beneath you. Engines ignite with a roar that compresses your lungs. Gravity presses you into your seat like an invisible hand trying to hold you back. For a moment, the entire planet resists your departure. Then you break free. Low Earth orbit is only 400 kilometers above the surface, roughly the distance from New York to Washington, D.C. It feels cosmic. It isn't. Astronomically speaking, you haven't even stepped outside your front door. The moon? 3 days away with Apollo-era technology. About 384,000 kilometers. A distant silver coin in the sky becomes a gray, cratered world beneath your boots. And yet, if you lived 80 years and spent every second traveling at Apollo speeds, you wouldn't even escape the outer edges of our solar system. Because space is not empty distance, it is scale weaponized. The outer boundary of the sun's gravitational dominance, the Oort cloud, extends nearly 100,000 astronomical units away. That's almost 2 light years. Our solar system is not a neat planetary diagram. It's a vast spherical shell of frozen debris stretching halfway to the nearest star. And the nearest star is still 24 light years away. That's Proxima Centauri. Light moving at 300,000 kilometers per second takes over 4 years to get there. The fastest spacecraft humanity has ever built, NASA Parker's solar probe, reaches about 200 kilometers per second at peak velocity. That sounds extraordinary. It isn't. At that speed, it would take over 6,000 years to reach Proxima Centauri. 6,000 years. Entire civilizations rise and fall in that span. Languages evolve. Religions emerge. Empires dissolve. Your name would be dust long before the ship crossed even a fraction of that distance. So, with conventional propulsion, the answer is simple. You will never reach another star. Not even close. But physics is not finished with you yet, because Einstein changed the rules. In 1905, special relativity shattered common sense. It revealed something that sounds impossible. Time is not absolute. It stretches and compresses depending on how fast you move. The closer you travel to the speed of light, the slower time passes for you. From Earth's perspective, decades might pass. From your perspective, only years. This is not theory in the poetic sense. It's measured fact. Astronauts aboard the International Space Station age slightly slower than people on Earth. Subatomic particles moving near light speed live longer than their stationary counterparts. Velocity alters existence. Now imagine a spacecraft capable of reaching 99% the speed of light. To outside observers, the journey to Proxima Centauri would take about 3 years. But for you inside the ship, due to time dilation, it would feel like less than a year. 1 year. Suddenly, another star is reachable within a human lifetime. Push further. At 9% light speed, relativistic effects intensify. The galaxy begins to contract in the direction you're traveling. Distances shorten from your perspective. 1,000 light years might feel like mere decades on board. And this is where the universe reveals its strange mercy. If you could maintain near-light speed long enough, you could traverse the entire Milky Way 100,000 light years, across within a human lifespan as experienced by you. But here is the cost. While you age perhaps 40 years, tens of thousands of years would pass on Earth. Everyone you knew would be gone. Your civilization transformed, your language unrecognizable. You would not return home. You would return to archaeology. Distance is conquered, time is not, and then we escalate again. The Milky Way contains roughly 100 to 400 billion stars. It is 100,000 light years wide. That sounds infinite. It isn't. Our neighboring galaxy Andromeda is too. 5 million light years away. Even at 999% the speed of light, something changes. The universe itself is expanding, not like an explosion into space, but as the stretching of space itself. Galaxies are carried apart on a fabric that grows between them, and at extreme distances, this expansion accelerates. There exists a cosmic event horizon, a boundary beyond which galaxies recede faster than light due to the expansion of space, not because they break relativity, but because space itself stretches faster than light can cross it. That means there are regions of the universe you can never reach, not in 1,000 lifetimes, not at light speed, not ever, even if you lived forever. So what is the absolute maximum? If you departed today in a near-perfect relativistic ship and accelerated continuously at 1 g comfortable, Earth gravity, you could cross the observable universe within about 45 years of your own experience time. 45 years. You could reach galaxies billions of light years away, from your perspective. But by the time you arrived, Earth would be tens of billions of years older. Stars burned out, the sun long dead, the Milky Way merged with Andromeda. Perhaps no humans left at all. You would become a time traveler, a survivor of your own epoch. But here is the final constraint. Even with perfect acceleration, you cannot outrun cosmic expansion beyond a certain limit. The observable universe has a radius of about 46 billion light years, but the reachable universe, the portion you could ever influence or visit, is smaller. Roughly 16 billion light years in radius. Beyond that, galaxies are already receding too quickly. They are lost to you forever. This is not a technological limit. It is a structural feature of reality. Your lifetime is not merely biological. It is cosmological. And suddenly, the question transforms. It's no longer how far can you travel. It's how much of existence is fundamentally inaccessible to any being that lives in time. The universe is 8 billion years old. It will expand for trillions more. Most galaxies will eventually drift beyond each other's horizons. Future civilizations may look into the night sky and see nothing beyond their local group. They will not even know a vast universe once existed. Cosmic isolation is the default fate of advanced life. So where does that leave you? You, with your 80 years. If you remain bound to chemical rockets, you won't leave the solar system. If you master fusion propulsion, you might graze nearby stars perhaps, a few dozen light years away. If you conquer relativistic travel, you could traverse the galaxy within your own lifetime but lose your era forever. If you approach light speed itself, you could cross cosmic distances unimaginable to your ancestors but never return to the world you left. And no matter what you do, there are galaxies that will always outrun you. Always. The final limit is not engineering, it is causality. The speed of light is not just fast. It is the universe's speed limit for information, influence, and connection. You cannot experience what you cannot reach, and you cannot reach everything. But here's the quiet twist. The atoms in your body were forged in ancient stars. Heavy elements carbon, oxygen, iron were born in supernova billions of years ago. In a literal sense, you are already made of distant galaxies. You are composed of matter that has traveled farther than you ever will. The universe has already crossed unimaginable distances to become you. So how far can a human travel in one lifetime? Physically, perhaps billions of light years, if relativity becomes your ally. Practically maybe a handful of neighboring stars. Emotionally far enough to never come back. But existentially, you are already as cosmic as anything that moves through space. And perhaps that is the final revelation. You don't stand separate from the universe trying to conquer it. You are the universe, briefly awake, measuring the distance between stars and calling it a journey. One lifetime, 3 billion heartbeats, an expanding cosmos. And somewhere between the limits of light and the fragility of flesh lies the answer. You may never reach the edge of existence, but existence has already reached you. Close your eyes for a moment and imagine this is it. One launch, one decision, one lifetime. The engines ignite beneath you, a controlled star roaring against gravity. The ground trembles, your chest tightens. Earth begins to fall away, no dramatically at first, but gently, like a secret being pulled back. You are leaving the only world your species has ever known. Now here's the unsettling truth. Even if you traveled faster than any human ever has, even if you pushed physics to its absolute edge, the universe might still be too large for your entire life to matter against it. Because space is not just far, it is absurd. The nearest star is over 4 light years away. Our galaxy is 100,000 light years across, and beyond it, Billions of galaxies more each, with billions of stars racing away as space itself expands. But something strange happens when you approach the speed of light. Time begins to slow for you. The universe shrinks in the direction you're moving. Distances contract, years compress, reality bends. So, here's the paradox you're about to face. The faster you go, the more the universe allows you to see, and the more it takes away from everything you leave behind. This isn't just a question about engines or fuel. It's a question about whether a single human life, fragile, temporary, finite, can ever truly step into something infinite. And whether, if you tried, you would still belong to the world you started from. You begin where every human story begins, under gravity. The ground holds you. The air presses gently against your skin. The sky looks vast, but it is a thin membrane just 100 kilometers thick before it dissolves into blackness. Space is not far away. It only feels far. The engines ignite. Metal shudders. Your body is crushed into the seat as acceleration builds. 3 times your body weight pins you down. The sound is not just heard, it is felt in your bones. And then, silence. Orbit. At 28,000 kilometers per hour, you are moving faster than a rifle bullet. Earth curves beneath you, blue and fragile. Continents slide past every 90 minutes. It feels cosmic. It isn't. You are 400 kilometers up. That is less than the distance between 2 major cities. If your lifetime is 80 years, about 5 billion seconds, and you spent every one of them traveling at this speed, you still wouldn't escape the sun's distant icy boundary. Because the solar system is not a planetary diagram. It is a cathedral of emptiness. The moon, 3 days away. Mars, 6 to 9 months with current propulsion. Jupiter, years. Pluto, nearly a decade. And even Pluto is not the edge. Beyond it lies the Kuiper Belt. Beyond that, the Oort cloud, a spherical shell of frozen debris stretching perhaps 100 times farther from the sun than Earth is. That's nearly 2 light years wide. Our solar system alone is almost halfway to the nearest star. Now feel the scale shift. The closest star system, Proxima Centauri, sits 24 light years away. Light, the fastest thing in existence, takes over 4 years to reach it. The fastest spacecraft humanity has ever launched would need thousands of years, not hundreds. Thousands. You would die before crossing even 1% of the gap. With chemical rockets, your lifetime barely dents interstellar space. But physics hides a loophole, and it is stranger than fiction. In 1905, Einstein revealed that time itself is flexible, not emotionally, not philosophically, physically. The faster you move, the slower time passes for you relative to those standing still. This is not speculation. It has been measured with atomic clocks. Astronauts age slightly slower in orbit. Subatomic particles traveling near light speed live longer than they should. Velocity stretches time. Now imagine a ship that can accelerate constantly at 1 g, the same gravity you feel on Earth. Comfortable, sustainable. You could stand inside it as it builds speed for months. After 1 year of continuous acceleration, you would approach relativistic velocity, a significant fraction of light speed. And then something extraordinary happens. From Earth's perspective, years are passing normally. From yours, time begins to thin. At 99% the speed of light, time slows dramatically. A journey that appears to take 4 years externally might feel like 1 year onboard. Push further, 9%, 99%, and relativistic effects intensify. The universe ahead compresses. Distances contract in the direction you're traveling. It's not an illusion. Space itself shortens, from your perspective. This is called length contraction. The galaxy begins to shrink. The Milky Way is about 100,000 light years across. At ordinary speeds, that is an impossible barrier. At near light speed, that distance compresses dramatically for you. With sustained relativistic acceleration, you could cross the entire galaxy within a human lifetime of subjective time. 40 years on board. But while you age 4 decades, tens of thousands of years pass on Earth. Every person you've ever known is gone. Languages evolved. Coastlines shifted. Perhaps humanity itself transformed beyond recognition. You would arrive at the far side of the galaxy as a relic of a forgotten era. You conquered distance, but lost time. Now widen the scale. The Milky Way is one galaxy among hundreds of billions. Our nearest major galactic neighbor, Andromeda, is 5 million light years away. Even light requires millions of years to cross that gulf. Yet under extreme relativistic travel, from your perspective, the journey could take only decades. Decades. You could outlive galaxies in your own frame of reference. But something even larger looms. The universe is expanding, not like shrapnel from an explosion, but like a stretching fabric. Every second, space itself grows. Distant galaxies are not merely moving through space, they are being carried away as the metric of space expands between us. And the farther away a galaxy is, the faster it recedes. At extreme distances, galaxies recede faster than light, not violating relativity, because they are not moving through space faster than light. Space itself is expanding. This creates a cosmic horizon, a boundary beyond which events can never affect you, no matter how long you wait. No matter how fast you travel, there are galaxies whose light will never reach Earth, and if you launch toward them today, accelerating perfectly, you would never arrive, not because your ship fails, but because reality refuses. Even with continuous 1g acceleration, even pushing arbitrarily close to light speed, the reachable universe has limits. Beyond roughly 16 billion light-years, cosmic expansion outruns any possible pursuit. Those regions are causally disconnected. They are permanently outside your story. This is not a technological problem. It is a structural property of spacetime. Now pause. Let that settle. Even if your biology were solved, even if your ship were perfect, even if fuel were infinite, the architecture of the cosmos itself restricts your journey. Your lifetime is not merely constrained by aging, it is constrained by geometry. Yet within that geometry lies something astonishing. If you accelerated continuously for about 20 years, then flipped your ship and decelerated for 20 more, you could traverse distances that appear billions of light years across from Earth's frame. To you, it might feel like a middle-aged journey, but you would emerge into a future tens of billions of years ahead. Stars like our sun would be dead. The night sky would look unfamiliar. The cosmic microwave background radiation would have cooled further. Entire galactic clusters would have drifted beyond one another's horizons. You would not just be traveling through space. You would be time-traveling forward into epochs no one from your birth era could ever witness. The faster you go, the further into the future you arrive. Distance and time are not separate. They are braided together. So how far could a human travel in one lifetime? If bound to current propulsion, not even one star. If advanced fusion or antimatter drives become real, perhaps a handful of nearby systems within decades. If relativistic acceleration becomes achievable across the Milky Way in subjective decades. If near-perfect relativistic travel is sustained across billions of light-years of observable space from your perspective. But here is the hidden cost that grows with every escalation. The further you go, the less your origin survives. Travel far enough, and you detach not only from place but from era. Your home becomes history. Your civilization becomes fossilized memory. Eventually, if you traveled long enough at extreme relativistic speeds, the cosmic background radiation ahead of you would blue-shift heating space in front of your ship. Interstellar particles would strike with devastating energy. Even sparse hydrogen atoms would become lethal projectiles. At sufficiently high velocities, the universe itself becomes hazardous. Space stops being empty. It becomes a wall. There is a practical ceiling below light speed where shielding, energy, and physics conspire against you. And above all of it stands the ultimate limit. You cannot exceed light speed, because to do so would require infinite energy. Light is not just fast. It is the boundary between possible and impossible. So the true answer unfolds in layers. In ordinary human terms, your lifetime barely reaches beyond your planetary neighborhood. In relativistic terms, your lifetime could span galaxies, but at the cost of everything you leave behind. In cosmological terms, there are realms you will never access, no matter what. And yet, there is one final twist. The atoms in your body were forged in ancient stars billions of years ago. The carbon in your cells, the iron in your blood, all born in stellar explosions long before Earth existed. Matter has already traveled farther than you ever will. You are composed of recycled galactic debris that crossed cosmic distances before assembling into you. In a sense, you are the endpoint of a journey far longer than any spaceship could achieve. So perhaps the question shifts again, not how far can you go, but what does it mean to travel? Is distance measured in kilometers or in transformation? Because if you left Earth at near light speed today, you would return, if you returned at all, to a world that had moved on without you. You would be a visitor from the past, a relic carrying memories no one shares. The further you travel, the more you sever continuity. And that may be the deepest limit of all. Not fuel, not propulsion, but belonging. In one lifetime, you might cross billions of light years from your own perspective, but you can never carry your entire world with you. And as the universe continues to expand, accelerating, isolating, stretching galaxies beyond reach, the ultimate horizon quietly advances, not just around you, but within you. Because every second you spend chasing distant stars is a second your own finite clock ticks forward. And even as relativity bends time, your heart still beats. 3 billion times, give or take. That is your internal universe. Finite, precious, unstretchable. So the real frontier may not be how far you travel through space in one lifetime, but how much of the universe can fit inside one.